Hello and welcome to the Weekly Space Hangout for Wednesday, April 25th, 2018. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about NASA finally has a new administrator. Gaia dumps 1.7 billion stars on us. Was there an advanced civilization before us? And the most mind-bending animation from Rosetta you've ever seen. Apologies in advance, podcast people. Joining me this week, we've got... Whoops, I totally wrecked my windows. Oh no. All right, let's see if this will still work.
Can't handle this.
Joining me this week, we've got whoever is on my screen. It's Carolyn Collins Petersen, former contributor, author. She's back. She's got a book. Carolyn, welcome back.
Thank you.
Let's advance sneak preview. We're going to interview you at the end of the episode, but come on, sneak preview. Let's see the book.
Did you want me to hold up the book? Here
Yeah, I will ask this.
What a beautiful cover!
What a wonderful cover for the podcast.
And I
people.
do judge books by their covers.
Yes, you do.
Opening them is so much work.
On my screen right now, we've got Dr. Morgan Renberg, the Director of Scientific Presentation at the Fort Worth Museum of Science and History. Morgan.
Happy podcast day.
Oh, Kimberly's not here, so somebody has to say it.
Got to do the work.
And we've got Dr. Paul M. Sutter, astrophysicist at Ohio State, chief scientist at COSI, host of Ask a Spaceman, and my traveling buddy, Paul.
Yeah, we like to hang out. It's
in
fun.
Iceland.
And yeah, you live stream, there has to be some sort of value add to the YouTube and the live stream, so it might as well be beautiful images.
Paul is wearing a stunningly blue shirt today.
It is so blue.
It's intensely blue.
It's lovely. It has numbers on it too.
It's 90.5 WCBE, Columbus.org. WCBE.
You're log rolling on the stream in clothes.
Is that where you do your show?
Yeah, that's Space Radio. That's the home station for Space Radio. I also record Ask a Spaceman in their studios there. They let me borrow. Yeah.
All right, well, before we get started, I want to give a shout out, as always, to our good friends at the Weekly Space Hangout crew. These are, of course, the producers, the people who organize behind the scenes. They contribute to the chat. They're the lifeblood of this whole show. So a big thanks. If you want to join this awesome community, go to wshcrew.space and they'll hook you up. All right, let's get on with this week. And let's start with the NASA finally getting an administrator, probably. Morgan.
Man, NASA's long leadership-less nightmare is finally over, as this week Jim Bridenstine, formerly Congressman of Oklahoma, was confirmed very, very narrowly to be the next administrator of NASA. NASA hadn't had an administrator since President Trump took office last January, making this by far the longest period of time in the agency's history that it had lacked a formally recognized administrator. If you had to characterize Jim Bridenstine, I think probably it would be two things. One is a general denial of climate change, and the second is a broad support for the commercial spaceflight program. As a congressman, he was active in pushing a bill that would really turn over low Earth orbit to commercial entities and refocus NASA on missions beyond low Earth orbit. That's a policy that has seen some support, I'd say, so far in the Trump administration, and is likely to really continue. And so I think if you're somebody who's looking to see more opportunities given to a SpaceX or a Blue Origin, then Bridenstine is the administrator for you.
People have been asking me all week what I think. And
what do you think, Fraser?
Well, I'm glad you asked. And what I think is, I don't know, is that I've got let's imagine that I had many hands, more hands than I have. And so on the one hand, he is clearly a big space nerd. He is absolutely into space exploration. I don't know about his interest on the science side of it, but he definitely has been getting involved in advocating for space exploration even before he took on this position. At the same time, he's not a scientist. And this is sort of one of the things that's so great to have some of the previous administrators. They've been scientists, they've been astronauts.
Yeah, he was a pilot for the U.S. Navy prior to entering Congress.
He has said some pretty skeptic-y things about climate change, which is a little unnerving for the director of the agency.
Did you walk that back recently?
Well, and so then he has recanted on the climate change things.
He walked a much more moderate line during his confirmation hearings.
Yeah.
But that's not an unusual thing to do for somebody who is facing a challenging confirmation, as he was. He was, only Secretary DeVos in education was confirmed by a slimmer margin than Jim Bridenstine. And so I think had he remained as strident as he's been in the past, that wouldn't have happened. And so I'm not sure that we know whether that's a marker of an actual change in his beliefs or simply sort of talking the talk long enough to get where he is.
And so I guess what I've been saying is just like until he takes an action, he is Schrodinger's administrator. Carolyn, what do you think?
Well, all of the things you guys have said, plus he has been not very respectful of people's human rights, particularly for women and women in the gay community and non-religious people. So I saw him try to walk some of that back in his acceptance speech, where he did emphasize an inclusive NASA. Now, I will be really interested to see if he follows through on that, and I remain to be convinced.
Yeah.
Yeah, from a policy perspective.
Sorry, the climate change part bothered me quite a bit. I did quite a lot of work last year in learning more about how to speak about climate change, and I just really felt like he didn't have a good understanding of what he was talking about.
It's sort of hard to know how strongly to feel about a NASA administrator because in some ways they don't really have that much power. A lot of NASA's policy is set by Congress. A lot of it is dictated by the White House. The administrator isn't a cabinet level position, so they don't even have sort of the amount of gravitas that say a Secretary of State or Secretary of the Interior might have. So in some ways, they're a figurehead who's going to do what the administration wants, and that's true sort of irrespective of who is sitting in that chair.
Yeah, I heard a great conversation with sort of from sort of what the person who works in the administration, sort of what really their role is. And their role is to translate the demands from Congress into workable solutions. And so a lot of the times it's Congress and the president are the ones who are actually calling the tune that they are then attempting to fulfill on. I know I'm mixing a bunch of metaphors here. So in many cases, I mean, this is part of why NASA did great without it, or, got through, I wouldn't say did great, but survived without an administrator for the length of time that it did, because really NASA is about all these people who are doing the work day in and day out and are receiving all of these instructions from Congress about what the high level requirements are.
Even not high level. I mean, look at how finely tuned a bunch of the NASA budget is. As like, you're going to spend this much money on this subject at this location. It's like, there's not a lot of flexibility because so much is directly mandated by Congress.
So Morgan, what are some things? Oh, go ahead.
I was going to say, in one way, it's useful that he has the experience he does working in the legislature, so that he would be able to sort of speak their language and maybe, but he is going to be on the hot seat. There's no question about that. And, I think the biggest question will be what the executive wants him to do.
So Morgan, what are some actions maybe that we could be watching for that would tell us that he is trouble? What do you think?
Well, I think we should keep an eye on the way in which he talks about the various NASA priorities. NASA is an agency that has a lot of different responsibilities that I think people don't always think about. There's the fundamental tension between human space flight and robotic exploration. There's the question of sort of basic aeronautics research. There's support for studying the Earth, whether that's climate change or, say, the GRACE mission that measures the gravity of Earth to track things like aquifers. NASA has a lot of far-flung missions. Which parts is he choosing to emphasize, and which parts is he choosing not to? Again, there's only so much he can do. In some respects, Congress chose to fund the Earth observing and Earth science component of NASA basically to the full amount that they've been doing in the past, and he's going to have to spend that money. But the rhetoric that he uses will shape the way in which Congress views NASA's role in Earth sciences going forward. And he has basically an unlimited platform to speak in that sense.
Yeah, man. I guess that's it. We're just waiting on tenterhooks to see what happens. And as soon as actual actions are taken, then I'm sure we will either praise or criticize those actions. I mean, when you're looking at the NASA budget for this year, it's hard not to praise it, right? Everything got what they wanted, and in fact more. So that's great. So let's keep that going. Just keep rolling with that momentum, Jim. You guys are doing great. All right, Paul, let's move on to what I think is the most important story of the year so far.
Gaia is huge.
Yeah.
And I think this is one of those things where you're like, wow, okay, a data release. And it doesn't sound really sexy because it's not like we discovered some new thing about the universe or in ancient civilization that predates humanity or whatever. But it's just a giant chunk of data. The power here isn't in like the sexiness or the big splash of this result. It's the fact that there's a giant chunk of data, and astronomy is has been for hundreds of years on getting big catalogs, getting precise information, in leveraging that, using that to learn other things. So the Gaia mission is a satellite. It's been up for a few years, has been getting incredibly precise positions, velocities, spectra, the whole deal on billions of stars. And which is approaching, there's 300, 500 billion stars in the Milky Way. But it's approaching like a good fraction of a respectable fraction of the stars in the Milky Way galaxy. Like, it's a lot of stars. And so much fundamental astronomy relies on just having this basic information about a star. Like, hey, I wonder how far away that star is. And from that, you could look at an object and you could be wondering, is this just a normal star that's relatively close by? Or am I looking at a really far away star that's also really, really bright? Until you get a good parallax measurement of that star, you can't really know for sure. And until you know for sure, you can't infer a lot of other properties about the star and its neighborhood and its history and everything about the galaxy. It's just this incredibly rich, detailed portrait of our home galaxy, plus a bunch of other stuff, like 13,000 solar system objects.
Yeah.
Over 1 billion stars with precise parallax and positions, hundreds of millions of more with lower quality data, but still really solid. It's just, there's some extragalactic stuff in there. It's
going to find planets. It's going to find quasars.
It's accidentally taking pictures of quasars and planets.
Yeah.
I mean, in some ways, it's making the fundamental measurements of astronomy, like the really basic things, like where the heck are these things? What do they look like?
Mm-hmm. How are they moving?
Yeah. I'm really interested to see if somebody can come up with clever ways to combine Gaia data with some of this really high quality photometric data that we got from Kepler and that we'll be getting from TESS. Because then you'll have a population of hundreds of thousands of stars for which we know very precisely where they are, how they're moving, how their brightness is changing, what's in their local environment, and to a statistical value across the whole Milky Way. And there's got to be valuable information that can be pulled out of that we just haven't even had access to in the past.
Actually, I was reading the press materials that they sent out about this, and it was reminding me of when I was first going back to graduate school, and I had my advisor tell me, well, astrometry used to be a really boring science. Nobody wanted to do this. And now we have this sort of the ultimate satellite doing this, along with others. And you're seeing things like the paper that they cited about the Sculptor galaxy, the Sculptor dwarf galaxy, that they've now been able to determine its highly elliptical orbit around the center of the Milky Way, which is pretty cool.
Yeah, I mean, this is one of those things, like, people keep digging up information out of, say, the Sloan Digital Sky Survey. Of course, I just keep going on and on and on about the LSST, that there are all of these just great big data sets that people are going to be digging through using computers for years and years and years.
So where are all these exoplanets? I remember this was one of the things that Gaia had promised, was thousands of likely exoplanet discoveries. What are we waiting for to get them? Do they just need more data?
The candidates might be in there. It wasn't really highlighted in any of the public releases, but you have multi-epoch observations of the same stars, which means there should be transit events just buried in the data. It's just a matter of, assigning some poor grad student to go find them.
Well, and the astrometry
follow-ups.
Yeah, the astrometry method, I think, was supposed to give us a lot of far-off planets, because astrometry, unlike basically all other exoplanet search methods, is best at finding things that are far away from the planet. And that's a part of the sort of parameter space of exoplanets that we really haven't probed. And so I'm eager to see what we find a long way away from host stars, to see if it's very different than what we're used to finding sort of in our solar system type distances.
Yeah, I mean, maybe just this data set was the release of the stars, and then they also went out of their way to show all of the asteroids. They mapped a whole, 200 asteroids on an animation, but then also measured that they had another, 12,000, 19,000, some enormous number of asteroids that they had additionally mapped. So maybe we're going to see more data results coming out. Clearly, we need to have someone from Gaia here on the show.
Oh, yeah.
That would be great.
Usually in these big data releases, they'll have, this data has been available within the collaboration for some amount of time as they've been polishing it for the data release. And internally, usually, all the researchers, the collaborators have access to it, and they're doing a bunch of science and getting their preliminary results ready. And now that it's public, I think in the coming months, we're going to see boom, 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 paper after paper after paper after paper citing this database and showing us some cool science results.
They're already there. I was looking through AstroPH today, and there's a ton of stories that are just about the Gaia release, data release. So they're already all over it. And Arjun just posted a question in the chat. Has anyone created an actual 3D map of the Milky Way using data like this? Every time I see our galaxy represented, it seems they're using a generic galaxy. I'm sure it's much more interesting. I can't even imagine a computer being able to handle a map, like actually 3D rendering a map with 1.7 billion data points.
So most of these stars are still relatively close to the Earth, if you're thinking on galactic scales. They're not like evenly distributed throughout the whole galaxy. And so we don't really we could build a very detailed model of our local part of the galaxy, but the stuff that's farther off, we still have to rely on other methods to see, because the farther away something gets, the harder it is to tell that it's moving, and that's the fundamental piece of observation that Gaia needs to figure out the distances to things.
Yeah, and I mentioned this is a respectable population of stars. It's still 0.3% at best, the percent of stars in the Milky Way galaxy. And it's going to be, like Morgan said, it's going to be biased towards the nearby stars. Gaia does get some far away stars, but it's only going to be the brighter ones that it can capture. It can't see dim and far away stars. It can only see close and or bright.
Man, but it's pretty cool, I gotta say. This is one of the big announcements that I've been really looking forward to this year, and I'm really glad that it did come out, and I suspect we're all going to be covering it over and over and over again. They say in their release that the final catalog is coming out in 2020, and that'll be sort of the final full data set, although I'm sure Gaia will just keep rolling for years and years and years after that until it, runs out of, I don't know, reaction wheels, which
they only packed a couple.
So what I'm going to do quickly here, and I apologize to the folks who are listening to this on a podcast. I'm so sorry, but now I'm going to show you just this most amazing video that made the rounds over the last 24 hours on the Twitters, and then a bunch of us reported on it. And so I'm going to put this up on the screen for the folks that are watching this live, and I'll try to describe it. So what we're looking at here is a image or a sequence, an animation of frames that were captured by the Rosetta spacecraft of the surface of Comet 67P. And actually, it was doing it while it was orbiting, so it's not actually landing on the comet. And then you can see what look like there's the white streaks that are sort of in the front are these cosmic rays that are hitting the detector. The sort of things that are floating around in different directions, those are probably dust that are illuminated by the sun. And then the background is, you can see sort of the constellations of the stars that are sweeping past. And so there was just a citizen scientist on Twitter who stitched together all of these frames that came from the Rosetta mission. And it's funny, I went back and I was able to actually find them on the Rosetta site. Like all of these frames were there waiting for somebody to stitch them together, but to actually stitch them together is just this absolutely stunning animation of what it would be like to be floating near just near the comet. And so I highly recommend, I'm sure if you do a search for like animation, comet, Rosetta, on the Googles, you will see this thing, and it is just a mind-bending video. So did you guys, has everyone already seen this?
Oh,
yes.
yeah.
Yes.
It's the dynamism in it, I think, is what's so striking. Is often we see either stills from space or these really slow moving animations of spacecraft sweeping around in big long orbits. And I mean, it's just pandemonium. And that's what's so cool about it, is it feels like the spacecraft is right up there skimming over the surface and all this stuff is happening. And it makes you smile.
Yeah.
I feel like it's going to keep panning a little to the right and it'll reveal to be the island of misfit toys.
Just a little more to the right.
Just a little off.
Yeah. Well, is Rosetta down at this point? We're not going to get any more pictures from it. Aren't they going to wake it up at some point? Or are we done with it?
I think it's done.
I think they set it down on the comet, and that's that.
I don't think they set it down. Damn, we're the worst. We need to have someone from Rosetta too.
You need a chief scientist.
Yeah, we need a chief scientist. Someone in planetary. But yeah, so just an absolutely stunning image, stunning sequence. I highly recommend everybody goes and searches for it. Again, I apologize to the podcast people, but the video is just it's an amazing thing. All right, Paul, you posted what I think is going to be our interesting conversation for the day. There was a paper that was published saying if there was a civilization before human beings, would we be able to detect it in the geological record?
Right. Yeah. And so it's this Silurian hypothesis of, if there was an advanced industrial civilization on the Earth way before us, would there be any evidence of it? And the first challenge that this paper has to overcome is that there's absolutely no evidence for such a civilization in the fossil record. And we were talking about this before the show about, it's an interesting thought experiment of, if you didn't have the fossil record, then what will the geologic record tell you? But that's not my reading of the paper. That's not the approach they took. Instead, they just kind of hand waved away the entire fossil record, saying, oh, yeah, it's spotty and incomplete, so we can't use the fossil record. So instead, let's use the geologic record. And then it turns out using the geologic record is really hard for finding advanced civilizations. And it brings up some interesting events in the past tens and hundreds of millions of years, where there's been rapid changes in the various concentrations of gases in our atmosphere. And kind of sort of talks about it, like, even though there's pretty solid biologic and geologic processes that we think led to these extreme events, it says, well, maybe, but we're not 100% sure. I just didn't feel like it treated the historic and paleontologic records seriously in its analysis. And I'm still trying to figure out what this paper is supposed to teach us.
Let me provide a little bit a little more sympathetic context. There's sort of been an ongoing debate in the geologic community for the last maybe decade or couple decades about whether we've entered a new geologic era or epoch that has been proposed to be called the Anthropocene. And the argument for the fact that we're in a new geologic epoch is that we're making changes now to the Earth, whether it's to the water or to the air, that are going to or already are leaving permanent changes in the geologic record. So that if you came back a million years from now, you'd be able to see a change that is happening sometime around now, whether that was 10,000 years ago or 50 years ago or 10 years ago. That's sort of the range of ideas people have about when we might have started permanently changing the geologic record. And how I interpret this study is that, if in fact what is so remarkable about the period now is that we're so rapidly changing the environment that it's leaving geologic records, then that would be a bad definition if we could look back in time and find other times when such rapid changes in the environment were taking place that did not correspond to the arrival of some super species like human beings. And so we're going to go back, and we know basically that there wasn't a civilization in the past. But we're going to go back and apply this standard that we're thinking about using today to the past, and looking to see whether it sort of yields any false positives. And to do that, we have to pretend like we're on a search, even though we know that that's not actually a plausible thing to think.
And you can kind of imagine them looking on other worlds, right? Like, what if they go and look on the surface of Mars and examine the geologic record there? Maybe nothing turns up in the fossil record, but maybe something could turn up back then. And I guess it's nice to have independent lines of evidence. Adam Frank, so the two researchers behind this article, and it really is more of an article than it is a journal article, right? It's like it's something that they posted more for Popular Science. Adam Frank is the creator of the NPR 13.7 Cosmos and Culture blog, which I'm sure many people have read. And then his sort of co-writer on this is Gavin Schmidt, who is a climatologist from NASA, and he's the person behind the Real Climate blog, and sort of the main target, I guess, after Al Gore for a lot of the climate skeptics. And so I think, to just consider that idea. I mean, this idea that there was a civilization on Earth, obviously, the Doctor Who fans are all over this. which is where that name, the Silurian hypothesis, comes from. Apparently, they're some kind of reptile monsters that were here before.
Yeah, and Doctor Who that were buried under the earth and awakened by a nuclear test, I think. But so the word Silurian is already the name of a geologic age, which I think is where Doctor Who got the name.
Right. And so, you can kind of imagine from their point of view. And there's been some other great sort of thoughts about this idea, right? Like, not only are we going to look out into the universe for evidence of aliens around other worlds, but maybe there are archaeological, maybe there are various things that we could find even just here in our own solar system that could be some evidence of a past civilization. And one of the most likely best ways for an alien civilization to let us know that they're here is actually to 2001 build some kind of monument, build some kind of thing that if we found it would go, oh, okay, we're not alone in the universe, because there's no way this thing could form naturally. And so same kind of thing, you could imagine clues left behind on other worlds. So I like this idea of just kind of going, the fossil record, as you said, Paul, tells us clearly we are, there have been no advanced civilizations here on the planet, and you can kind of go all the way back to our common ancestors. But what about independent lines of evidence? So
I'm okay. Like I see where you're coming from, and I am sympathetic. I think asking the question, does our impact of the planet, will that leave a geological record that 1 million years from now, 10 million years from now, 100 million years from now, would anyone even notice that we were here? Absent the fossil record and our impact on the fossil record, part of the Anthropocene is the human caused extinction, which is its own record. But okay, so taking that way, that's fine. It's an interesting question to ask. I don't think the paper approached that question in the best way possible. And the paper led with a whole bunch of stuff on the Drake equation, which I also wasn't quite grasping.
All right. It's okay.
All right. Okay. Bring Adam on, and then
there you go. Yeah. I know I can see Nancy is like furiously writing down a bunch of names. So either one would be a party. I've had a chance to interview Gavin in the past, and he's a lot of fun and really knowledgeable, obviously on the side of climate science. And is has been out there on the front lines for so long. So it would be great to have a conversation with him. All right, well, let's move on to the interview portion of this week's episode. And our guest this week is also one of our co-hosts, and this is Carolyn Collins Petersen. Carolyn, it's been a while since we've had you here on the show. Welcome back, and give us an update.
Well, the reason I haven't been on this show is because I've been working on this book, and I had to just bow out of all known civilization until I got it done.
So when did it get published?
It was actually published in England in November, and didn't make it over here to the United States until the 1st of April.
It's pretty far.
Yeah, it's a slow boat. It's kind of a slow boat. Yeah.
So, and what is the title of your book?
All right. Do I hold it up again or not?
Yeah. Every time I mention the word book, let's see that book. Yeah.
There we go.
Space exploration, past, present, future.
Yeah, we really wrestled with that title, I have to tell you.
That is the hardest part.
They came to me about 2 years ago, and it's a little publisher in England that does a lot of books on technology, on traveling technology and transportation, but they also do historical books as well. So just recently they sent me a little press release that they have something about the greatest people named William in the royal family, kind of things. So they kind of go back and forth, but a lot of it is technology. So if you want to read about early canal barges in England or planes or something like that, they're your people. But they wanted to branch out and do a little bit more on space exploration. So they contacted me and said, We want something for people who are interested in space exploration, maybe didn't know they were interested, but they want to know something about it. So in other words, sort of the executive summary of the history of space exploration. And oh, by the way, can you do it in 120,000 words?
That's a very specific number.
Well, I have to tell you, you could do 120,000 words on the Gemini mission. So it was really tough. The biggest issue, the biggest challenge to do something like this is to figure out what you're going to leave out. So what I did was I decided to tell them I would answer the question, what does it take to build a spacefaring society or civilization? And start with the history. So we go back to, the Chinese fire arrows and the beginnings of flight, and they go all the way through all of the space race, World War II, the space race, into the future. And I end the book with a little bit of a forward look at a mission to Mars, because that seems to be on everybody's mind right now.
And so did you get it? I mean, one of the great things about being able to take that time and being able to write a book is you get to do a bunch of original research, right? You got a chance to, I'm hoping, got a chance to get down and like check some old archives. And I always like to hear those great stories of getting some of that original research. Did you get a chance to talk to some people?
Yeah. So one of them, well, no, yeah, I did, but I also spent some time at the library, and believe it or not, the internet is still an amazing source of information. However, if it's on Wikipedia, you do have to go check it out,
Yeah.
So one of the stories that really intrigued me was the development of the first rockets. And I didn't have a lot of time to go through this, but I did spend some time on it in the book. And the first rockets really aren't like the V2s and Robert Goddard and all this. You're going back to possibly as early as the 1st or 2nd century AD, to when people figured out how to stuff little tubes full of gunpowder and shoot them off somewhere. Now, they did say that most of the research that I did show that it really was the Chinese who perfected this, but there's some evidence that it also happened in the Middle East around 1 to 200 AD. Not completely clear that everybody knew what they had their hands on. They were just blowing things up.
Yeah.
But the Chinese were basically sent, yeah. Well, it was always war. And so they found a way to send these flaming arrows, the Chinese did. And they were showing them, basically, one of the accounts that I read was kind of funny. It was a kind of a poor translation, but they're basically saying, we had this great idea and then the Mongols stole it from us. And then they had fire arrows. So everybody's shooting fire arrows at each other. And then history moves on for a while. And the next time you really see anything about rockets isn't until around the 16 or 1700s, maybe a little earlier than that. And then it goes on, moves forward. And the next really big pulse of research into rockets really starts around Goddard's time, maybe a little bit before that. I'd love to find more. I'd love to find more about that. But that was just a little rabbit hole that I went down for about 3 weeks, trying to find.
Yeah. Well, and that's the thing, right? Is like every little nugget of information means you go back to the library, you take out another book, they pile up. Each one of them is its own adventure to go through and find those little snippets that are going to help you weave that larger story. It's writing a book. People say I forget who I was talking to. Someone said, I'm writing my first book and I think it's going to be a lot of fun. And I just said, said nobody who's ever written a book.
This is the 7th one I've worked on.
Yeah.
It's never fun. Well, sometimes it is. There was another section as you get forward, further into the late 1900s and the 20th century, you start getting into the concept of new space. And so I went round and around with some people about, well, what do you mean by new space? There was sort of a general, definition of what it really was, but it really amounted to, well, we're not like Lockheed. We're not like Martin Marietta and Lockheed and those guys. We're new, we're different, we're entrepreneurial, we have this spirit. Well, to get there, I needed to go and look at all of the companies that have been working in aerospace since basically the turn of the last century. And I ended up writing this chapter that I started calling the Begats, because you have one company starts out building something, Martin builds something, and then Lockheed builds something, and suddenly one buys the other one out, and then they spin off a section to a third company, Rocketdyne or something like that. And pretty soon you have this incestuous little relationship between 20, 30, 40 companies, and some of them now are claiming they're new space because they have new space attitudes. They're not new space like SpaceX is new space, but it's really kind of funny how they all kind of wrap around each other, buy each other out, sell each other out, buy it again. And the only people that really haven't done this yet are, Elon and Jeff and people like that. Give them time.
Yeah, that you figure.
They'll be buying each other out. Yeah.
Yeah. Well, we were talking about this last week, just how much SpaceX has come out of nowhere to utterly dominate the launch market and
Yeah.
what this is potentially going to look like moving forward. I mean, nobody now is even in the same league as what at the sort of launch capacity and the pricing that SpaceX is bringing to the table, not to mention what's coming next. So did, it's almost like events have been unfolding as you've been working on this book. Did that have any sort of impact on what you did?
Yeah, I need to rewrite that whole chapter, actually. So I turned in the book about a year and a half ago, and then I got it back 3 or 4 months later in layout, and then I could fix a few things in it. But when you write a book like this, you have to write very generally. And I could say Falcon Heavy is coming. I could say Falcon 9 does this. I could say Blue Origin does that. I could say Rocket Lab in New Zealand. Okay, they hadn't launched anything by the time I sent this out, or they'd done some testing. Now they've launched. So those are the kinds of things I kind of have to keep up on. But I did try to stay away from really up-to-the-minute reporting, because this isn't a book that comes out overnight. It takes 6 months or so for something like that to come out. And I'm looking at it now saying, well, I need to talk about Falcon Heavy a little bit more. SLS is another thing that was still kind of nebulous, what we're going to do with that and when it's going to happen. There are a couple of chapters on science that we've done in space exploration. I'm focusing on astronomy and planetary science, basically. And I was really lucky that James Webb was kind of put back. I basically said it was going to launch in the 2020s.
Oh, it's your fault.
It's going to launch in the 2020s, yeah. I didn't mean that.
You provided like a rough guideline to the folks at NASA, and they took you up on it. Thanks.
Yeah. Well, so those kinds of things kind of had to work on. But another thing that I also went into was, it isn't just hardware. It isn't just rockets that we're building. We're not just throwing hardware up there and bringing rocks back from the moon. Space exploration has also had the reverse effect on society. And so you have all of the, the legal issues, the treaties, all the things that we talk about in order to put things up into space. But it's also affected things like education, technology transfer, spinoffs, all that sort of stuff, art and science. In education, actually, music, dance. You see all kinds of effects of space exploration on movies, for example. I was just at a Star Trek science fiction convention last weekend here in Denver, and I brought that up in one of my talks, that we all wouldn't be here sitting in that big room if it hadn't been for Star Trek and Star Wars, the things that were taking some kind of inspiration from space travel, even if it was anchored in earlier science fiction that was written even before space travel started. But you go back and you look at this interface between early science fiction and space travel and the impending ideas of space travel. That was very much a closed loop feedback system, that they're looking at, these early writers are looking at rockets and ships to the moon and all of this, and they're writing about it. At the same time, you look at Star Trek and you look at the technologies that were written in there, and all of a sudden we have flip phones and things that look a lot like Star Trek stuff. And it can go on and on like that. So I did devote another large part of a chapter to that sort of feedback idea as well.
So, I mean, in writing a book that's sort of as comprehensive like this, being able to look kind of back and forth through the history of it and then into the future, did you get some kind of sort of overall feeling about where we are on that journey? Are we close to the beginning? Are we in the middle? I mean, I
think we're very much in the middle. But what I found was really cool is I went to do a count of the countries involved in space exploration. We always tend to think, well, it's China and the United States and Russia and this. There's 75 countries involved in space exploration. So whether they may not all be launching, but they're doing research, they're doing space exploration, they're doing space technology, and they're launching on somebody else's rockets. So it's a worldwide phenomenon now. And I think it's gotten this forward momentum that isn't going to stop unless we, annihilate ourselves or something. So I think it's pretty positive.
Which is why, of course, Elon Musk has said they want to colonize Mars. So let's talk a bit then, I guess, about the future. What is the scenario that you put together for how you think the future is going to play out over the next couple of decades?
Well, what I did was basically I anchored it to a trip to Mars, because we're talking about it. Elon's talking about it. China's talking about it. Russia wants to go there. Britain has mentioned it. I mean, a lot of people are talking about it. India is just a huge rolling, I don't know what you want to call it, sort of a megaton rolling village of people wanting to go to space. Every single time that I write about an Indian space launch, I get these dozens and dozens of messages from people in India. Hello, lovely lady. Thank you for writing about us.
Yeah.
They're so happy. We noticed. You know,
I
and
get
for them,
the same
it's a
thing.
matter
I
of
gotta
personal
do an
pride.
episode just on
Yeah.
what's going on with the
Yeah.
Indian space program, because there's a lot of super exciting things that are going on, and they're very proud of the missions they've done and the launches they've done. You know, they have a mission at Mars right now. They've got plans to send a mission to the moon.
They sent Mars orbiting mission, and they got it on the first try.
Yeah.
You know, I mean, this is pretty amazing. So I anchored this in a trip to Mars, and I sort of anchored it in the ideas of a planetarium show that I did a long time ago called Mars Quest, where we have this, we go through all of the history of Mars exploration, and then we basically take an about face. We go leap forward into the future and have this historian looking back at what it took to get us to Mars, and he's musing on all the things that it took to get us to Mars, and basically saying it's now our second home, and here's where we're going. And so I use that as part of the last chapter to say, here's where humans are going. And it's not going to be you and me, grandma and grandpa, or mom and dad basically reading this book. It's going to be our kids and our grandkids doing this, and they're the ones that are in school right now, and they're the ones that are going to be getting their PhDs and going out there and doing this kind of thing and building the rockets. And so we need to think about them.
No way. In like 6 years, the fleet of BFRs are taking off, and they're going to be just like rolling people out onto the surface of Mars. Haven't you heard?
Well, and Elon says we're all going to take these trips. So at least we're not doing the Mars One approach. So
you get to come home.
Yeah, you get to come back.
Yeah.
And basically talking. And at one point I thought about writing a short science fiction story at the end from the viewpoint of people who had been there, the second or third generation, and what it was like to live there and be there and have their kids and bring them up, and maybe have a few deaths along the way, and to show just how tough it was, because they're the pioneers, just like the ones that came out to the West and pioneered the United, the North American continent, and throughout history we've had this. So they were just basically the next wave of pioneers. I didn't get to write that story. I ended up doing the planetarium approach instead.
So now you said this was your eighth book?
Seventh that I've worked on, yeah.
So a glutton for punishment like that has got to be then, like, you're too far now. You're going to work on another one, aren't you?
I have a contract to do another one, yeah.
What's that one going to be about? Can you say yet?
I sort of can say it's about aspects of observatories.
Oh, good.
Yeah. So, no, the first one I ever did was a children's book. Oh, I might even have it here. Hold on, I'll get it. And I lost my headphones. See here? A children's book on Jupiter. And put my headphones back on now. I need to glue these into my ears. And then the next ones I worked on were things like about Hubble. My co-author and I, Jack Brandt, wrote the very first science book on Hubble science after all of the mess with the spherical aberration. And then I worked on a book called The New Solar System. I was actually an editor for that. I did another book with Jack. And then the last book I did, the very first one I ever did on my own after Jupiter, was a book that I don't have a copy of sitting right here, but it's called Astronomy 101. And that's still selling really well.
Oh, good.
And that's like 55 chapters, 55 1,000-word essays about astronomy.
That's epic.
Yeah.
So, and then you're also, for people who want to sort of see what you're up to, you're blogging, and now do you have time to write more regular articles?
I kind of do. Yeah. About 2 years ago or 3 years ago, how long ago I did this, I signed up to start writing for a group called about.com,
sure.
which is now morphed into something called thoughtco.com. And so I'm writing a lot of articles and editing a lot of articles on astronomy, space science, physics, geology, planetary science for them. And then I have my own blog, thespacewriter.com.
Awesome. Well,
I'm actually the CEO of a company that produces planetarium shows.
Yes.
And that's sort of off in the corner somewhere. No rest for the weary.
Speaking of planetarium shows, did you see this new show that's in the works in Saturn's rings? I think it's called.
I know about it. Yeah.
And they're making animations, but it's all based on photographs, so they're not actually doing any 3D animation. Right. It's all anyway. We're gonna have the creator on that in a couple of months.
Yeah, he's worked on this for many years.
Yeah.
I met him for the first time. We've talked to him on the phone because all of us in the Full Dome community have given him some advice on technical aspects of it. But he was at a meeting I attended at COSI a couple of months ago.
All right, well, let's give people a chance to shamelessly self-promote what they're working on before we wrap up this week's episode. Morgan, you've been coding.
Howdy. I have been coding, but I also had another great episode of SciShow Space drop this week, all about the IBEX mission, which studies the magnetic boundary of our solar system. I'll admit this is something I knew basically nothing about when I sat down to start writing the script, and it was really interesting to realize what we were able to do and how we were able to make these sorts of measurements from within Earth orbit. And that was just really awesome. So go check it out over at youtube.com/SciShowSpace.
Did you propose this topic and they accepted it, or did they go, oh, we want to know about this?
I am so bad at pitching that, like, 2 years ago, I told them, I will write anything that you want as long as I don't have to pitch. And so now they just basically give me the things that no one else wants, I guess. And it turns out to be an amazingly eclectic collection of topics. And I started off doing it just because I truly hate pitching. But it's turned out to be something that has taken me to all these parts of astronomy that I never would have thought to go to if I had to come up with topics myself.
Excellent.
So it's been a win-win.
Paul.
I'm going to keep pushing these Astro Tours. Go to astrotours.co because Fraser and I are going to Costa Rica and we want you to join us.
We sure do. Can't wait. It's going to be fun.
It will be. It's going to be an awesome trip. Costa Rica is a gorgeous, gorgeous country with beautiful skies.
All right, well, I'm going to shamelessly self-promote. I mentioned this last week, but I had just a live QA chat with my buddy Isaac Arthur on my channel this week, and we just hung out for an hour and talked, and it was a lot of fun, and people had a bazillion questions for him, and it was great to just sort of talk to him in an unscripted way so people could just find out more information about him and how he's sort of dealing with the speech impediment and what kinds of topics he sort of, can't wrap his mind around and keeps putting off. And it was a lot of fun. On next Monday, I've got Cody Don Reeder from Cody's Lab. And I just want to know how he's still alive, I think, is the question that I really want to know. So if you've never seen Cody's Lab, he's got about like 1.5 million followers on YouTube, and he does these great chemistry experiments, and I got a million questions for him. So come join me. That'll be on Monday at 5 to 6 Pacific time. So check that out. All right. Again, big thank you to everyone for watching us today. Big thanks to all the folks from the Weekly Space Hangout crew. We couldn't do this without you. We will see all of you next week. Thanks, everybody.
Bye.